Alright, today's 1.7, section 1.7, or this is section 1.7, properties of real numbers and simplifying expressions. We're going to talk about properties of real numbers, kind of what we can do with real numbers, and then the reason we're doing this is so that we can apply these properties of real numbers when we try to solve equations or solve expressions, because these will make things a lot, using these properties will make things a lot easier when we solve those expressions or simplify expressions. So the first step we're going to talk, I guess we're going to talk about a couple of these things. We're going to talk about the commutative property of real numbers, we're going to talk about associative property, identity and inverse property, distributive property, and we'll go from there. Alright, so these are again taken borrowed, used from the book. And these are just, again, the highlights of the book. So here's a property, commutative property of real numbers. Commutative means that you can just move things around. A plus B is B plus A. A times B is B times A. So 10 plus 5 is 5 plus 10. That's a commutative property of addition. And again, probably the names of these, commutative property of addition, probably not as important as just knowing that you can do A plus B is B plus A, and A times B is B times A. And again, we'll take a look at what we're doing with these. If we've got something like -3 plus -7, we can do, using the commutative property of addition, we can say that this would be -7 plus -3. Not real difficult, but again, when we try to simplify things, this will be helpful. If we take a look at 3x cubed plus 5x to the fourth, we can move the 5x to the fourth before that 5x to the, or sorry, 3x to the third power. And remember the sign that's in front of the term. Again, this is a term. This is a term. That's a term. They're separated by addition. Terms are separated by addition. And we can move this term to the front by saying this would be 5x to the fourth plus 3x cubed. The sign in front of each term goes along with the term. So this plus goes in with the 5x to the fourth power, and because we don't necessarily need to write a plus sign there, we can write a plus sign there, but if we don't have a plus sign there, we can simply say that there's a plus sign there. If there's no sign in front of a term, we have to assume it's positive. If that were not there, we'd have to assume it would be positive, and that would be correct. And because, again, the same idea, if there's no plus sign in front of that 3x cubed, we have to put the plus sign over here because it's separated from this term here. That 3x cubed is separated by the 5x to the fourth by a plus sign. So we can move these back and forth. So that's, again, the idea of the commutative property of real numbers. We can just move things around, move the terms around in different ways to make things easier for us to look at. The same idea holds true for the commutative property of multiplication. This is especially true, or probably especially helpful when we're solving equations. If we've got 10 times 5, we can say that's 5 times 10, and the same idea is you get to 50. But if you've got 12 times a -6, you can also say that it would be -6 times 12. You could also say that it would be -1 times 6 times 12. And then that -1 comes out in front, and that would be 6 times 12 would give you 72, and -72. Again, kind of simplified here, but the idea is that you can move these around. This is especially probably helpful for things like x times 4. Well, x times 4 is the same as if we use the commutative property of multiplication, we could say that that would be 4 times x, or also 4x. And again, this is not as pretty in terms of math as this. So we'd like to have the numbers, the coefficients, in front of the variables. So 4x is better than x times 4. And we can go from here down here by using the commutative property of multiplication. Next property is the associative property of addition and multiplication. And again, not so important to remember that it's associative property of addition and multiplication, but the idea is that you can move these parentheses around to say that instead of 5 plus 10 plus 2, you can say that it's 5 plus 10 plus 2. It makes things easier to add up. Over here, it makes things easier to multiply. And let's take a look at some ideas behind it. Here's the official properties right down here. A and B can be associated together, or B and C can be associated together, as long as all of them are added together or subtracted. Same thing holds true. A times B times C is, if you're associating A and B, you can also associate B and C together to make things maybe prettier, or simpler together. So if we've got y plus 5 plus 6, we can say that it's also, by associating the 5 plus 6 together, we can say that it's y plus 5 plus 6, and then it would be y plus 11, which y plus 11 is a lot simpler and straightforward than the y plus 5 plus 6. Same thing holds true for the s. This would be x plus 4 plus 3. To make things easier, to make things prettier, to make things more compact, maybe, that would be x plus 7. Again, if we've got 4 times 5 times z, we can say that it's, well, 4 times 5 times z. Well, what's 4 times 5? 20. And then z is right there. And again, that's prettier and more mathy, I guess, and more compact than the 4 times 5z. We're just moving those things together by associating the 4 and the 5 together to make 20 when they multiply together, and then z is just a variable. Same thing holds true for this over here. If we've got negative 3 halves times negative 2/3 w, this will come in handy when we're dividing by or multiplying by an inverse to isolate a variable on one side. We could say on one side of an equation, let's say. This would be negative 3 halves times negative 2/3. And if we associate these together and multiply by w, then we can multiply the negative 3 halves by negative 2/3. And if we multiply, if we look at fractions, the 2 and the 2 would cancel. 2 divided by 2 is 1. 3 divided by 3 is 1. We can throw that away as something that divides to 1. And then negative times a negative is a positive, and that equals simply w. So this kind of complex simplifies down to here just simply to w by using the associative property of multiplication. So there's our associative properties of multiplication and the commutative properties of real numbers.